So hello everyone, it's Quintickle here with another video. Today it's actually going to be a different video than usual because today we're actually coding something in a time lapse. I'm going to be coding Conway's Game of Life, which is a very simple game, and I'll be explaining the rule. That's why I have the little frame there, and then I'll be going into coding it and all that. So Conway's Game of Life is actually pretty basic. It's basically Conway's Game of Life. Let's name it that way. Seagull. Alright, so basically you have a bunch of squares. I'm only going to work with a grid of 5 by 5 for the purpose of showing you this. So basically it's a lot of cells. So it's just a lot of cells that you can see, and a cell can either be alive or dead. And I'm going to mark a dead cell with the letter X, and an alive, no, actually I'm going to mark the alive ones with an X, and the dead ones I'm going to leave empty. So let's say you have an alive cell, and an alive cell here. So basically each frame, the program checks for the following rules. If a cell is alive, so if the cell is alive, it'll look around it in all the 8 directions, in every single one of them. And it'll count how many alive cells are around it. If there are less than 2, it'll die because of overpopulation. And if there are less than 3, it'll die again of overpopulation. And if there are 2 or 3, nothing happens. Nothing happens. It lives a happy life for the next frame. But what if a cell is dead? Because we have to test the dead cells as well. So I'm going to mark this one just to show you what happens there. So if the cell is dead, then it'll look around it. Let's say here. It looks here. It looks here. It looks here. Here. Here, looks here, here, and here, and counts how many neighbors of its are alive. And if there are 3 neighbors, so if the cell is dead, and it counts its neighbors around, and if they're exactly 3, but exactly 3, the cell becomes alive. Cell alive. Because of reproduction, I guess. And if not, nothing happens. So this is how the Game of Life works. It's just a few basic rules, 4 rules to be exact. So if a cell is alive and it looks around it, and less than 2 neighbors of it are alive, then it'll die. If more than 3 are alive, it also dies. And if there are exactly 3, it lives. If a cell is dead, and it has exactly 3 neighbors around it that are alive, it will revive. Basically, it will turn alive because of reproduction. So let's jump straight into coding. So, first of all, I need to get the logic implemented in this game. I will start by creating my grid using the init window function in graphics.h. I will be using a 100 by 100 grid in which each pixel will be made of square of 10 pixels by 10 pixels. I will start by making the classes, adding properties and constructors. The main classes will be a cell class having the alive property, and a board containing a matrix, which is an array of arrays, of cells, and a few methods. The most important methods are nextStep, which calculates the next frame, and getNeighbors, which counts how many alive cells are around a specific cell based on its position. I'll test everything to make sure it's alright. Now sit back and enjoy. the graphics are going to be pretty easy, just a simple function that draws pixels at the given coordinates. It's pretty basic, so I won't be including the clip, but I will be including a time lapse of the graphics running, and we can see how it works. It's not doing anything wrong, but we can see how each frame is rendered, which is not good for visuals. This is happening because I am clearing the screen after each frame, which causes the screen to blink. In order to fix that, I will need some optimization. Here's a quick video of that happening. The way I am planning on optimizing all of this is simple. I will create another matrix that will hold the last frame, and instead of clearing the device, I will go through the current frame and the last frame and change on screens if the pixels don't match up. But this is also too slow for our purposes, so I had to think of a new way of optimizing everything. So I decided that in every next step function, I will create an empty vector, dynamically allocated, containing all the changes made during the recalculation of the frame. Then, when redrawing, simply going through the vector to see what changes have been made, changing the screen as well. And you can see in the video how I've implemented this. And now that everything has been completed, here's a time lapse of what we have ended up with. Enjoy!